So today we're going to be looking at phase changes and phase diagrams. So a phase change is a reversible physical change when a substance changes from one state of a matter to another. We talked about this some when we talked about physical properties. We looked at melting point and boiling point and talked about how they're a physical change. During a phase change, the temperature of a substance will remain constant. It will not change. So when it's actually making the change, the temperature doesn't change. Energy is either absorbed or released during a phase change. So if it's endothermic, the system absorbs more energy from the surroundings. I like to think of this one because endo sounds like in, and absorbs is like it's going into it, okay? So then we have exothermic, and the system releases energy to the surrounding. This one is like exo, like exit. So the energy is exiting. Okay, so that's a phase change. Let's look at different types of phase changes. So here's the descriptions of them. So some of them you know already. So if we go from a solid to a liquid, that's melting. Or if we go from a liquid to a solid, that's freezing. You see those things every day pretty much. And then you'll also know gas to liquid, which is condensation. You can think of that like the water that gathers on the outside of a glass or on your car windows when the temperatures are different. And then you know evaporation. That one's liquid to gas. Then you have a solid to a gas. These are the ones you might not know. When it goes from a solid to a gas, that's sublimation. Best example of this is dry ice, if you've ever seen it. It goes straight from a solid to a gas. And then deposition is gas to a solid. I don't see this one very much in real life, but we'll do it sometimes in the lab. Okay. So if you want to pause, make sure you write this all down. You have Cornell notes that I've posted that you can use. You're going to make a poster of these things. That's one of the assignments that is posted. What I want you to do is draw this diagram and make sure you write down the words in the right places. See if you can test yourself by not using your notes to do that. And then on each of the arrows, I want you to draw or put a picture or write an example of something that when this happens. So I'd like you to do ones that are that you see every day, except for maybe deposition and sublimation. You can Google those and see what you can find. So let's talk about evaporation versus evaporation. So evaporation is what we actually see. That's when a material changes from a liquid to a gas at the material's boiling point. So we heat it up, and then it changes from a liquid to gas at that boiling point. Evaporation is when material changes from a liquid to gas at the surface of a liquid and at temperatures below the boiling point. You might have seen this if you've ever seen like steam or like foggy stuff on top of a pond. What that is water actually evaporating, but the whole pond isn't that temperature, right? No, just the surface has been heated up. So that's why that's evaporation. So now we're going to move on and look at phase change diagrams. Here's the first one. So if we're looking at water and we slowly increase the temperature, you see that when it actually changes states, so at that number 1, it doesn't change temperatures. All that energy goes into changing it from one to another. Or if you look at 100 degrees, all that energy goes into changing it from one to another. So the temperature stays the same. This is one type of change, a state change diagram, with temperature and energy. It shows us when that happens and where all that energy goes. So conservation of mass and energy. During phase changes, mass and energy are both conserved. What does that mean? This means that neither mass nor energy can be created or destroyed, but it changes forms. So think about that. When you are melting ice, that water is changed into something else. It changes to liquid water, but none of it disappears. Okay, that's true when we go from a liquid to a gas. All of that material changes into something else. It doesn't just go away. And that energy doesn't disappear either. You saw all the energy we're putting in, it goes into doing something. Okay. Next, we're going to look at phase diagrams of water. You can see there's a YouTube link up there if you'd like to watch it. But what we have is temperature and pressure. So at the bottom down there, we have temperature going from low to high. And up the side, we have pressure going from low to high. And then on that diagram, we have the different states that we learned about last class. We have a solid, a liquid, and a vapor. Okay? So if we have a low temperature and a kind of medium to high pressure, you're going to have a solid because that puts you there. But if I have a low pressure and a high temperature, it's going to be a vapor or a gas. Let me change colors real quick. Gas. And then if you have kind of a medium temperature and a high pressure, you'll have a liquid. Now I want you to think about this. What are those black lines? What happens when we go from a solid to a liquid? It's the melting point, right? So that's the line that is melting. Or if we go from a liquid to a gas, this is boiling. So that line is like the boiling point, okay? Right here, where all those 3 points meet, this is called our triple point. That means that all 3 states can happen there. And then up here at the critical point, everything above it is going to be a supercritical fluid, okay? So this right here is our critical point. And after that, above it, to the side, is going to be that supercritical fluid. So here's another picture that shows us that. We have the solid and the liquid and the gas, temperature on the bottom, pressure up the side, and then those lines are where the different things happen. If I move from a solid to a liquid, the line is melting. If I move from a liquid to a solid, it's going to be freezing. And then here's our triple point, and there's our critical point where equilibrium can happen. So let's look at this with numbers, okay? So if I have a temperature of like 50 degrees and a pressure of 1, I'd go up here saying that's about 50, and there's our 1, and I would be a liquid, okay? Now what about if I'm right here? I have a pressure of 1 and a temperature of 100. That's going to be where our boiling point is because we're going from a liquid to a gas. Here's our point down here where all 3 lines meet. It's at 0.0098 and 6.0 times 10 to the negative third atmosphere, which is what we're measuring pressure in. Okay, so what happens if I am right here where those red lines cross and I decrease my pressure? It becomes a gas. Or if I go back to the spot and I increase temperature, it's going to become a gas. Okay, and up there, once again, we have that critical point. So if I am at that 217 and I want it to become a gas, I can increase my temperature until it becomes a gas. Or I could decrease my pressure until it becomes a gas. See how we can do that? Okay. All right, if you have questions about these phase diagrams, let me know. Try watching that YouTube video first. There is a worksheet posted for you to do over there. So you have 2 assignments from this lesson. You have a poster that we talked about earlier, and then you have just a worksheet. All right, I'll talk to you later. Bye.